Exercise 11. Write an inequality whose solution set is the sketched region. Okay, after we look at this region for a moment, one thing comes to mind, and that's that the region is a half plane. So, observe, the region is a half plane. Now, if we've done that, this implies then that a linear inequality will work. Okay, a linear inequality is needed. Well, first thing would be getting the boundary line. The boundary line equation. Here's the boundary line. What about that equation? Well, let's see. One approach you might take here is you might think about y equals mx plus b, slope-intercept form. And in this case, let's see, m is the slope. Well, here's a clearly marked point. Here's another clearly marked point. The slope is rise over run. In words, as we go from here to here, the rise is down, so negative 1, 2, 3. The run is 2. So this negative 3 over 2 is our rise to run, or the slope. B is the y-intercept. Clearly here, it's 3. Okay, so now we have our boundary line. It's y equals to minus 3/2 x plus 3. Now, since we have our boundary line with y solved for here, a y equals to f of x formula, and now we can think in terms of, do we want to have above the line or below the line as solutions here? Surely we want above the line, so we can think of that then as becoming a y. Alright, we want the greater than. The boundary line, notice, is solid, so we'll need this to be or equal to minus 3/2 x plus 3. Okay. Now, let's give this a check. Here's a way you can check. Now, 0, 0, the origin, is not in the region. So, upon substitution, 0, 0 should make this inequality false. So we could here test 0, 0 should make the inequality false upon substitution. Let's see what happens. 0 for y. 0 greater than or equal to negative 3/2 times 0 for x plus 3. What about 0 being greater than or equal to 3? Okay, that's false. That's what we wanted to see. Okay, so a little bit of confidence in our answer that's in the prominent cloud. Looks good. Exercise 13. Write an inequality whose solution set is the sketched region. Okay, well, first thing we probably notice is that this region is a half plane. So, observe the region is a half plane. Okay, what this implies then is that a linear inequality will work. Alright, Well, let's get the boundary line. The boundary line equation. So we're looking at this dashed line here, and, well, let's see, the information we know about it is this very clear y-intercept at 0, 4, and this other point, the x-intercept, also very clear, negative 3, 0. Alright, well, we might choose to think in terms of y equals mx plus b. That's slope-intercept form. And let's get the slope here. The slope. Rise over run as you go from left to right. From this point, the rise is 1, 2, 3, 4. The run is 1, 2, 3. Okay, rise to run, 4 over 3. That will give us our slope. B is the y-intercept. Clearly here, it's at 4. Alright, so our boundary line looks like y equal to 4/3 x plus 4. Now, since we have this boundary line as a y equals f of x type of formulation, we can think of this in terms of, do we want above the line or below the line? The region is clearly above the line. So we're going to use a greater than inequality. Now in this case, also notice the boundary line is dashed. So we don't want the boundary line to become part of the solutions of our inequality. That means we need to make this simply y greater than, no equals to, just greater than 4/3 x plus 4. And this apparently is our final answer. As a check, just to make sure we didn't make some mistake here, we could take a real easy to deal with point, real easy for arithmetic anyway, upon substitution, 0, 0, the easiest of all perhaps. And so we could substitute 0, 0 into the inequality. It must make a false statement, because 0, 0 is not in our region, not in the solution set. Okay, let's see what happens here. 0, and how about that being greater than 4/3 times 0 plus 4? This simplifies to 0 greater than 4. Okay, that's false, and that's just what we wanted to see. So it adds a little bit of confidence to our solution here. It's not a foolproof check. An error could get by us here, but at least we probably are 95% of the time going to be correct. Okay. Exercise 15. Write an inequality whose solution set is the sketched region. Alright, by examining this region for a minute, it's apparent that this region is a half plane. Okay, we know what kind of inequality we want then. We should use a linear inequality. That's the implication. Alright, well then we need the boundary line. Okay, let's work on the boundary line equation. Here's this boundary line. Let's see, what do we know about it? Okay, apparently we have these two very specific points. We can work off of that. It might be a good opportunity to use a point slope form of a straight line. So that is y minus y1 equals m times x minus x1. Again, that's called point slope form. Alright, well, let's see. Let's get m. Another formulation, the rise over run, or the change in y over change in x, would become a y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, let's call this the first point and the second point. So our y sub 2 becomes a 4, minus our y sub 1 becomes a 2, x sub 1 becomes 3, x sub 1 is a negative 2. If we subtract negative 2, that's plus 2. And so this simplifies to 2 over 5. And a little graphic check for consistency at this point of the question. Does this look like a slope of 2/5? This line clearly has a positive slope, since when you ride along it left to right, you're going uphill. And you expect a number less than 1 because if you imagine the perfectly diagonal line, 45 degrees, this is not as steep as 45 degrees, so it should not have a slope even as much as 1, which it doesn't. Okay, so things are looking pretty good. Well, we can let either one of these points play the role of x1, y1. Now, it might be easier to use this point since it has no negatives for the coordinates. Alright, so now this can become y minus 4 equals m, known to be now 2/5, x minus 3. Alright, so we have this boundary line. Now, maybe we would like to just have an isolated y, so then we can think in terms of above or below the line as far as our inequality goes. So we could take this a little bit further. This equals 2/5 x minus, this looks like 6/5 then. Now let's add 4 to both sides. Y becomes equal to 2/5 x. 4 is 20/5, so this would give us 20/5 minus 6 of fifths would give us 14/5. Now a little bit of check on the situation right now, and that's that this is now in slope-intercept form. Alright, now we're claiming a y-intercept of 14/5. That would be 2 and 4/5. Is that consistent with the graph? 1, 2, and about 4/5. This does look pretty good. Alright, so we're confident with ourselves up to this point. Now, what to do about our inequality? Since we have this looking like a y equals to f of x, we can think of terms of above or below the line. And we clearly want to be below the boundary line, so we will choose a y less than. We also want the boundary line to be solutions. This is a solid line here, so we include the equal sign here as well. Ultimately, we want to then say y less than or equals to 2/5 x plus 14/5. Okay, and just as a final check on our work here, let's take 0, 0. The point 0, 0 is in the region. Okay, this implies that upon substitution, the inequality should become a true statement. Okay, here goes our check. 0 for y less than or equal to 2/5 times 0 plus 14/5. This simplifies to 0 less than or equal to 14/5. What do we think about this? True. And that's our check. Okay, looks good. Exercise 17. Write an inequality whose solution set is the sketched region. Okay, looking at the sketched region, we see a half plane. So observe the region is a half plane. Alright, so we can use a linear inequality. That's the implication here. This implies that we can use a linear inequality Alright, let's get that boundary line. That boundary line equation. We see a horizontal line. Alright, so we know that it's going to be y equal to a constant. That's a horizontal form in the world of straight lines. And in this case, that constant is here, -2. Now, do we want to be above or below the line? Well, clearly we want to be below the line. Also, the line is solid, so we need to make our boundary line part of our solution set. We will need the or equals to case as well. This gives us y less than or equals to -2. Okay, and as a very quick check, you can consider 0, 0. If you consider that, 0, 0 is not in the region, so it should make the inequality false upon substitution. Must make inequality false upon substitution. Well, put it in there. Let's see, 0 for y, 0 less than or equal to -2. No, -2 is further to the left than the number line, so this is false. That's what we wanted to see. Okay, this looks good. Exercise 19. Write an inequality whose solution set is the sketched region. After looking at this sketched region, you probably noticed it's a half plane. Okay, and more good news is that there is a boundary line here whose equation is even given to us. Okay, so the boundary line equation is sitting right here. 2x minus 5y equals 10. And we notice it is a solid line, so this inequality is going to be an or equals to type. But now, what about the direction of the inequality sign? Do we use a greater than or a less than sign? So how can we do that here? Determine the type of inequality. What we can do here, for example, is to say that 0, 0 is not in the shaded region. So 0, 0, upon substitution, must yield a false statement. So 0, 0, upon substitution, must yield a false statement. Okay, let's substitute in and see what we have here. this would be 2 times 0 minus 5 times 0 on the left. On the right will be 10. This is 0. This is 10. Okay, let's put an inequality sign here that makes this false. Well, 0 is actually less than 10, so if we had a 0 greater than 10, this will be what we require to make it false. Okay, so now we know to put a greater than type inequality in our final inequality, and so we're going to be left with 2x minus 5y greater than or equal to 10. Just in case we went a little too fast, made an error, a check. Okay, maybe now we choose a point that is clearly in the solution set. Maybe out here. How about 4, negative 1? Okay, 4, negative 1 is a solution because it's in the shaded region. So let's substitute this into the inequality. This would be 2 times 4 minus 5 times negative 1. And the inequality is like this, greater than or equal to 10. Let's simplify this side here. 2 times 4 is 8, minus a negative, that's plus 5. That's 13. How about 13 being greater than or equal to 10? That's true. And that's just what we expect to see by choosing a point, which is a solution upon substitution. It should make the inequality true. It does. This looks pretty good.